we want to use Descartes' rule of signs, so it'd be great if we knew what that said. And what it says is that the number of sign changes of the coefficients of f of x, or in this case g of x, but we use f as our standard, is equal to the number of positive real zeros of the function plus 2k, where k is equal to 0, 1, 2, etc. Okay, so and the number of sign changes of the coefficients of f of negative x is equal to the number of negative real solutions. Oops. Plus 2k, where k is a non-negative integer. And let me explain what that means. I have g of x is equal to 3x to the fourth plus 5x cubed minus 7x squared minus 8x plus 5. Okay. There is no sign change between 3 and 5. It's a positive 3 and a positive 5. But there's a sign change. So that's our first sign change. To negative 7. But then negative 8, no sign change. To positive 5, that's our second sign change. So there are either 2 or 0 positive real zeros. There cannot be 4 positive real zeros. There can only be at most 2. And then that number declines by 2's. So g of negative x is equal to 3x to the fourth minus 5x cubed minus 7x squared plus 8x plus 5. Now check to make sure I did that correctly. Negative x to the fourth does not change sign, but this one does. Negative x squared does not change sign, but this one does. Okay. So from 3 to negative 5 is a sign change. To negative 7 is not. To positive 8 is our next sign change, but to positive 5 is not. Which means that there are either 2 or 0 negative real solutions. Now, it's important to note that that does not mean rational solutions. It just means real solutions. Now, what this means is that if I'm looking for the solutions to, or zeros, not solutions, zeros. Solutions to g of x equals 0. If I'm looking for all of those roots, and I find one real root or one real zero, there has to be another one, because I can't have only one positive. Okay, if I find a negative one, there has to be another one. And so it helps me eliminate my options when I'm trying to find all the roots of a larger degree polynomial. Now this one, they are real solutions, but they're not rational solutions. So I can't show you. But for example, if I were looking for rational solutions, I would have to check all of these combinations. So plus or minus 1, plus or minus 1/3, plus or minus 5, plus or minus 5/3. And if I were to find one positive, that would eliminate, or I mean, that would mean that there has to be at least one other positive. So I would know to keep looking.